Have you ever wondered what a glacier is? Well, imagine a colossal mass of perennial ice originating on land from the recrystallization of snow or other forms of solid precipitation that reveals signs of past or present flow. Yes, that's a glacier. Now you might be thinking, how big does this ice mass need to be to qualify as a glacier? Well, the exact parameters for size, longevity, and flow are somewhat elusive. But consider this: a tiny snow patch that persists for more than one season is hydrologically almost identical to a true glacier. An international group even suggested that any persisting snow and ice masses larger than about 0.04 square miles should be considered glaciers. Glaciers come in various shapes and sizes, and we can categorize them into three main groups. First, we have glaciers that extend in continuous sheets, spreading outward in all directions. We call these ice sheets if they're the size of Antarctica or Greenland, and ice caps if they're smaller. Second, we have mountain glaciers, which are confined within a path that directs the ice movement. Finally, there are glaciers that spread out on level ground or on the ocean at the foot of glaciated regions, known as Piedmont glaciers or ice shelves, respectively. It's important to note that glaciers in this third group are not independent. They are categorized based on their sources: ice shelves with ice sheets and Piedmont glaciers with mountain glaciers. And when a complex of mountain glaciers buries much of a mountain range, we call it an ice field. You might be asking, what influences the fluctuation of the world's glacier cover? Well, it's a complex puzzle that we're still piecing together. We know that periodic changes in the heat received from the sun, caused by fluctuations in the Earth's orbit, correlate with major fluctuations of ice sheet advance and retreat on long time scales. But the large ice sheets themselves contain several instability mechanisms that might contribute to larger changes in the world's climate. One such mechanism is the high albedo, or reflectivity of dry snow to solar radiation. As an ice sheet expands, it causes more of the sun's radiation to be reflected back into space, less is absorbed on the Earth, and the world's climate becomes cooler. Another mechanism is that the thicker and more extensive an ice sheet is, the more snowfall it will receive in the form of orographic precipitation. A third instability mechanism comes from parts of an ice sheet, known as ice streams, which may periodically move rapidly outward, possibly due to the buildup of a thick layer of wet, deformable material under the ice. While the ultimate causes of ice ages are not known with certainty, scientists agree that the world's ice cover and climate are in a state of delicate balance. So to summarize, a glacier is a large mass of perennial ice that originates on land and shows signs of past or present flow. They come in different types, including ice sheets, ice caps, mountain glaciers, Piedmont glaciers, and ice shelves. And their presence and fluctuations have a significant impact on our global climate. The mystery of glaciers continues to unfold as we strive to understand more about these fascinating icy giants.